Hello, this is Dr. Hanaa Assil, and this is Pearson Edexcel International A-Level, Unit 6. This is the exam that was in June 2023. There are practical skills in Chemistry 2. So let us take a look at the questions and discuss the answers. So the first question here was, a student investigated two aqueous solutions labeled P and Q. Both solutions were green. Each solution contained one cation and one anion. Tests were carried out on solution P. Of course, when he tells you that the solution was green, that immediately gives you an idea that we either have chromium ions or iron 2 ions. So he did the first test. A few drops of aqueous sodium hydroxide were added to P, and he decided there is chromium 3 ions. So if there is chromium 3 ions and I add aqueous sodium hydroxide, what do I get? We get a green precipitate. Remember, this is a few drops. So at the beginning, you get green precipitate with chromium 3. Now he's going to add more sodium hydroxide until there was no further change. If there is chromium ions, we get with sodium hydroxide green precipitate that dissolves in excess, forming a green solution. This is the result we get with chromium. If it were iron 2, the precipitate would not dissolve. So remember that the difference between chromium 3 and iron 2, both give a green precipitate with sodium hydroxide, but with iron 2, the precipitate does not dissolve in excess. With chromium, the precipitate dissolves, forming a green solution. Okay, then he says a few drops of dilute nitric acid were added to 5 centimeter cubed of a fresh sample of P. A few drops of aqueous silver nitrate were added to this acidified solution. He got a white precipitate. Well, the question is, silver nitrate is a test for what? You should know that silver nitrate is a test for chloride, bromide, iodide. Now, if we get a white precipitate, what is the formula of the anion? And please be careful, is he asking for the name or the formula of the anion likely to be responsible for the white precipitate? We said if we get a white precipitate, it is chloride ion, which is Cl-. State why in the silver nitrate test on P, the nitric acid was not needed in this case. Justify your answer by considering the role of the nitric acid in the silver nitrate test. When we do the silver nitrate test, why do we first add nitric acid? You should remember that we add nitric acid to remove any other ions that could form a precipitate. For example, carbonate ions, if they're present, they will form a precipitate with the silver nitrate. So we should add nitric acid in order to remove any carbonate. But here, we should know that there is no carbonate, because if there were carbonate, the chromium carbonate would not dissolve to form a green solution when we added the sodium hydroxide. So the fact that we had only a green solution when we added excess sodium hydroxide, that tells us that we did not have chromium carbonate in the first place. So carbonate ions were not present, so we did not need to add the acid to remove the carbonate. The student carried out tests on Q, so that's another solution, and inferred that it was a solution of iron 2 sulfate. So he found that Q is iron 2 sulfate. The addition of dilute aqueous ammonia to a sample of solution Q produced a green precipitate which changed color on standing. Explain why the color change led the student to infer that the Q contained iron 2 ions. So, if I have iron 2 with the sodium hydroxide, I get a green precipitate. But he's saying it changed color on standing. That is because when you have iron 2 it forms a green precipitate, and then if we leave it to stand, it reacts with oxygen in the air and becomes oxidized to iron 3. So what we see is that the green precipitate on the surface becomes brown. So that's what he means by changing color. And why did it become brown? Because the iron 2 was oxidized by oxygen in the air to iron 3. Describe a test and its positive result that the student could have carried out to show the presence of sulfate ions. What is the test for sulfate? And they ask this question a lot. Test for sulfate ions, what do? Add nitric acid, aqueous barium nitrate, a white precipitate is formed which indicates the presence of sulfate ions. Identify by name or formula a metal cation other than chromium 3 and iron 2 which could give a green color in an aqueous solution. So which of the transition metal ions give a green color in aqueous solution? He says already we know chromium and iron 2. What else? You should realize that these are the transition metals that form green color in solution. We have vanadium 3+, nickel 2+, in addition to the iron 2+ and chromium 3+. Okay, the second question says two organic compounds X and Y are colorless liquids. Each compound contains only one functional group. A few drops of deionized water was added to a beaker containing X and he got misty fumes. So he added water to X and he got misty fumes. A drop of concentrated ammonia on the tip of a glass rod is placed in the misty fumes and he got a white smoke. Remember that when you put concentrated ammonia on the tip of a glass rod and it gives white smoke, that means that misty fumes formed at the beginning were HCl. So deduce the functional group present in X. What did we have? What is it that we can dissolve in water and gives HCl? Well, I have an acyl chloride. Acyl chloride is a C double bond OCl. If it's hydrolyzed by water, it gives HCl that forms misty fumes, and when we bring concentrated ammonia near it, it forms white smoke or white solid of ammonium chloride. State the precaution that you would take to minimize the risk of carrying out this test on the misty fumes. Assume gloves, safety goggles, and laboratory coat are worn. So don't mention any of these. If I'm working with an experiment that is giving out fumes or gases, what is the precaution? You have to tell him, do the experiment in a fume cupboard. Any experiment involving gases must be done in a fume cupboard. Carbon-13 NMR spectrum of X has two peaks. If you remember carbon-13 NMR, if it has two peaks, that means I have two different carbons or two different carbon environments. So we know now that it is an acyl chloride. It's something that has COCl and it has two different peaks. So what would be the formula? This would be the formula. It has two different carbons and it has an acyl group at the end. The mass spectrum of Y is shown. So, bubbles are observed when aqueous sodium hydrogen carbonate is added. We will come back to the mass spectrum. Bubbles are observed when aqueous sodium hydrogen carbonate is added to Y. Deduce the formula of the ion responsible for the peak at M/Z45. Now, 45, if I add hydrogen carbonate to something and it gives bubbles of gas, that means I have an acid. Remember that sodium hydrogen carbonate or sodium carbonate with acid gives bubbles of carbon dioxide gas. So he says I have a part of my molecule that has M over Z45. That is my acid group, which is the COOH. So you have to write the formula. He's saying deduce the formula. Remember that anything from the mass spec must be indicated that it is a positive ion. The species that gives rise to any peaks in the mass spec is a positive ion. So this is how you write the formula of the acid group with a positive ion. Now he's saying draw the structural formula of Y. Now, I know that it's something that has acid, and I look at the mass spectrum and I look for the molecular ion peak. Where is the molecular ion peak? It's at 74. That means that the MR of my molecule is at 74, and it's an acid. So this must be the structural formula of the acid in order to have an acid group with a molecular mass of 74. Both X and Y can be used to produce esters. Name the compound that would react with both X and Y to form ethyl esters. I want to make an ethyl ester. So I need to react the acid with ethanol. So if I have the acyl chloride with ethanol, it gives me an ester. If I have the acid with ethanol, it gives an ester. So I need to react them with ethanol in order to have an ethyl something. A student prepared an ester using X and a suitable compound. Explain why the student added aqueous sodium hydrogen carbonate to the reaction mixture to allow the presence of an ester to be detected. Remember that when we prepare this, we have an acid, so we need to remove the traces of acid in order to allow the fruity smell of the ester to be detected. The presence of the acid masks the smell of the ester. You cannot smell the ester if there is acid, because it has a unique smell also. But if we remove the traces of the acid, now I can tell that there is an ester from the fruity smell. Both X and Y react with concentrated ammonia, but they form different products. Identify these products by name or formula. So what was X? Remember, X was this. It was the acyl chloride. Now, if I react ammonia with an acyl chloride, what I get is the amide. So the product that I get is the ethanamide, or the amide group. Y was this. So it's an acid. Now, if you react ammonia with an acid, what you get is the ammonium salt. So this is the ammonium propanoate. Question 3 says, this question is about an experiment to investigate the kinetics of the reaction between iodine and propanone with an acid catalyst. The equation for the reaction is shown. To obtain the order of reaction with respect to iodine, the concentration of iodine in the reaction mixture was determined at various times. So the procedure was mix 25 centimeter cubed of sulfuric acid. He's mixing it with propanone. Start a clock. Solution of iodine is added. Mix the reactants. Tip a spatula measure of sodium hydrogen carbonate into a conical flask. After 3 minutes, pipette a sample of the reaction mixture into the conical flask and mix thoroughly. And then he will titrate the iodine in the sample with sodium thiosulfate using a suitable indicator. Repeat steps 3 and 4 to obtain 4 more titers. So, state why the sulfuric acid and propanone concentrations are both much larger than the iodine concentration. Remember, I'm trying to determine the effect of concentration of iodine on the rate. So usually we put the others at a very large concentration. Why? So that they are almost constant. So that the concentration of the sulfuric acid and the propanone remain almost constant, so that the rate will be affected only by the concentration or the change in concentration of iodine. State why sodium hydrogen carbonate is used in step 3. Remember, we added to neutralize the acid so that we quench the reaction. We want to neutralize the acid and stop the reaction. Name the indicator that would be used stating the color change that would be seen. Remember, if we have iodine produced or used up, we use which indicator? We use starch solution, because in presence of iodine it is dark blue black. Once the iodine has been used up, the dark blue black color changes to colorless. Titration results from the experiments are shown. Plot a graph of titer against time. Now, he wants you to plot a graph. We want time in minutes versus the titer in centimeter cubes. That's the first thing you do, label the graph. And we need to use as much of the graph paper as possible. So we need to spread out the graph. The results in the table start from the lowest is 12.95. And it goes from 12.95 to the highest is 16. So I don't want to start from 0, or I will have all my graph on the top there. So we don't need to start from 0. We can start from 12 or from 12.5. And we can plot the points, and then, so I started here from 12.5 actually, and we plotted the points, and then we join it and we find that it is a straight line. Please use as many of the points as possible. So this is a line of best fit. State why the volume of thiosulfate may be used for plotting the graph rather than concentration of iodine. We did not plot the concentration of iodine. We plotted the volume of thiosulfate, and that is because the volume of the thiosulfate is directly proportional to the concentration of. So state the order of reaction with respect to iodine using the graph. Well, looking at the graph, we can see that this kind of graph indicates that the concentration of the iodine is not affecting the rate. So this is what we call a zero order. Okay? Further experiments were carried out to determine the reaction orders with respect to propanone and sulfuric acid. A graph of concentration of propanone against time is shown. So this is the concentration of propanone now. And he's saying determine the two half-lives. Obviously, from the graph, this means that this is first order if the half-lives are almost equal. So we know how to calculate half-life. We start from point 2. At point 1, from point 2, concentration point 2 to concentration point 1. How much time did that take? That's my first half-life. So it took about 7 seconds. And from point 1 to 0.05, how long did that take? That took about 8 seconds. So this is approximately constant half-life, and that means this is first order as he indicated. Then he says a graph of the reaction rate against concentration of acid now. So we've already talked about iodine. We said it is zero order. Acid, now he's giving me this graph and he's saying deduce the rate equation for the overall reaction of iodine and propanone with the acid catalyst. So what information do we know so far? We know that he says the reaction is first order with respect to propanone. And we drew the graph and we said it is zero order with respect to iodine. And the graph that I have there, what does it indicate with respect to acid? What order is it with respect to the acid? Obviously, if you have a straight line, like this graph between the rate and increase in concentration of acid. That means this is first order with respect to the acid. So how do we write the rate equation? We said the rate equation is K times. It's K times what? It was first order with respect to propanone and first order with respect to H+, and it was zero order with respect to iodine, so we don't need to include that in the rate equation. Question 4 says a group of students prepared methyl 3-nitrobenzoate by the nitration of methyl benzoate. So he's starting with that compound on the left, methyl benzoate. He's adding nitric acid, so this is a nitration reaction to give methyl 3-nitrobenzoate. So his procedure: measure 9 centimeter cubed of acid into a small dry conical flask. This is sulfuric acid. Label the flask A, place it in an ice bath. He added 4 centimeter cubed of methyl benzoate, so we're starting with 4 centimeter cubed of the reactant. Gently swirl the flask, mix with concentrated nitric acid and sulfuric acid and so on. Place a thermometer, add the nitrating mixture very slowly. Take care to ensure the temperature does not rise above 15. So he wants to keep it cold. Remove flask A from the ice bath. Allow it to stand at room temperature for about 10 minutes. Pour the reaction mixture into a small beaker containing crushed ice. Stir the contents of the beaker with a glass rod. Allow the ice to melt. Separate the solid by suction filtration. Wash the solid with a small amount of deionized water and then with a little ice cold ethanol, and recrystallize using ethanol as the solvent. Determine the melting temperature of the purified crystals. So, what's the question? An ice bath is a mixture of ice and water. Suggest an advantage of using an ice bath rather than a beaker containing only ice cubes. He's trying to keep the reaction cold. So we usually do the reaction or put the reaction in an ice bath. Ice bath is actually a mixture of ice, as he said, and water. Why is that better than just having ice cubes? Of course, this means there is larger surface area in contact with the cold ice bath than if I just have cubes of ice. Some of it will be touching the beaker and some of it will not. So we usually have a mixture of ice and water because this will give more effective cooling. Side products form if the temperature rises above 15 degrees. So I don't want it to rise above 15 degrees because I don't want it to do other reactions to give what we call side products. Give the structure of one side product that may form. We need to react it in order to form one nitro group on the benzene ring. If we leave it to react more and more, that means it will add more and more nitro, or it will put it in different positions. So he wants one side product. Actually, there are several possible side products. Putting 2 NO2s like this, or putting the one NO2 but in the different position on the benzene ring, or putting 3 NO2s on the benzene ring. So any one of these could be your answer. One student drew the suction filtration apparatus in step 6 as shown. Of course, this is not an accurate diagram for the use of the Buchner funnel. Identify the 3 ways in which this diagram is incorrect. You may assume that the apparatus is suitably clamped. So what is wrong with this suction filtration apparatus? Of course, this is what it should be. So he has the Buchner funnel, but he did not put a filter paper. He needs a filter paper. And then he has the flask closed. We need a side arm to go to the pump, because the idea is we're trying to suck the solution through the Buchner funnel or through the filter paper so that we filter it efficiently. So what is wrong with this? There should be a side arm, that's one, and it should be going to a pump to reduce the pressure, and we need a filter paper placed in the Buchner funnel. Describe the stages in recrystallization of methyl 3-nitrobenzoate in step 7, stating which stages are required to remove the insoluble and soluble impurities. Okay, what is he trying to do? He's trying to recrystallize, and in step 7 he told us that he is trying to recrystallize it using ethanol as the solvent. And that means my crystals will dissolve in the ethanol. So the first thing I do is I add a small amount of ethanol. I don't want too much. And I need to heat it to point of crystallization. Now, while it is hot, I should filter it in order to remove the insoluble impurities. And then I leave the solution to cool. This will form crystals. Then I filter the crystals, wash with a few drops of distilled water to remove the soluble impurities, and we get the crystals as a residue. The crystals must be dried before the melting temperature can be determined. Methyl 3-nitrobenzoate cannot be dried by addition of a solid drying agent, such as anhydrous calcium chloride. So just why the addition of a solid drying agent is not suitable to dry any solid. If I'm trying to dry a solid product or a solid substance that I'm trying to make, I don't add a solid drying agent, because that means you're mixing two solids together. How are we going to separate them? So we do not use a solid drying agent to dry any solid. We use it to dry liquids. It would be difficult to separate the solid drying agent from my required solid. State how the crystals could be dried. Okay, I cannot add a solid drying agent to dry it. How do we dry our solids? Between filter papers, right? Okay, the mass of dry methyl 3-nitrobenzoate crystals prepared by one of the students was 3.05 grams. So when the student made this experiment and prepared these crystals, he got 3.05 grams of the crystals. Calculate the percentage yield of the compound using the data shown. How do we calculate percent yield? In order to calculate percent yield, I need to calculate the theoretical yield first. So what are we trying to do? We're trying to prepare this compound, methyl 3-nitrobenzoate, and he said at the beginning we added 4 centimeter cubed of the reactant. So the one I'm starting with, methyl benzoate, I added 4 centimeter cubed. I need to get the number of moles. How do we get the number of moles if I have a liquid? Then I use density. Density is mass over volume. So the mass of the methyl benzoate is density times volume. He gives me the density in the table, and he says we used 4 centimeter cubed, so my mass is 4.32 grams. Then I can use this to get number of moles. So the number of moles of the methyl benzoate is mass over molecular mass. He gives me the molecular mass. This gives me the number of moles. Now, looking at the equation, it's obvious that the number of moles of the reactant is the same as the number of moles of product. So now I have the number of moles of my methyl 3-nitrobenzoate. Then I can get the mass. Mass is number of moles times MR. Number of moles is what we got. The MR he gives me in the table. So this tells me that the theoretical mass that he should have obtained is 5.75. How do we get percent yield? Percent yield is what he got over the 5.75 times 100. So this gives me a percent yield of 53%. Last question. melting temperature range of methyl 3 nitrobenzoate is given in a data book as 78 to 80 degrees Celsius. Suggest a melting temperature range for a sample of the methyl 3 nitrobenzoate before recrystallization. Before recrystallization means when it was impure. Now, if I know that the melting point of something is 78 to 80, what if it was impure? What would be the melting point? Well, first of all, you should know that the impure substance would have a lower melting point and a wider range. So if he says that the pure is 78 to 80, then the impure should have something lower than that and with a wider range, so something like 73 to 78 degrees Celsius. Okay, and that's the end of this paper. I hope this was useful to you. Thank you for listening.